Unit 11, more topics on lipid metabolism. This unit is much easier, much shorter than the previous unit, but if you still want to break it down into small parts, we're going to be talking about 1,2-DAG-3P and glycerol phospholipids, glycerol phospholipid degradation, sphingolipids, cholesterol synthesis and regulation. We can review AMP kinase and steroid hormones. I'll ask a question about biosalts and isoprenoids, the very last slide in the unit. So the first, page or two of slides I've summarized into this sort of graph. So kind of looks like a lot at first, but stick with it. It's kind of summarizing a lot of information, but putting it together that flows nicely. So the main point here, the overview, is you're trying to make 1,2-DAG-3-phosphate, also called phosphatidate, and from there you can make triacylglycerides, acidic, realize I'm not on the screen, acidic glycerol phospholipids or neutral glycerol phospholipids. We'll talk about those three options at the end, but they can basically start out by either glucose or tag. So if we're starting with glucose, we're going to go through glycolysis up until DHAP. I'm going to use a new enzyme called glycerol 3-phosphate dehydrogenase, and that's going to make glycerol 3-phosphate. It's a dehydrogenase, so it's going to be nice and dependent. We use an NADH. The other way to get to glycerol 3-phosphate is to start degrading some stored fat here, and you've had some fatty acids here jump off. 3 fatty acids have gone away, and all you have left is the glycerol backbone. So then we're going to phosphorylate glycerol with glycerol kinase using an ATP. So these are two separate pathways to make glycerol 3-phosphate, both leading to the same thing. Glycerol 3-phosphate looks like this. Every time I draw out this box, that's the glycerol. We have carbons 1, 2, and 3. So attached to 1 and 2 is an OH, and then attached to the third one is the phosphate. So you're going to start with the glycerol 3-phosphate, and you're going to start adding fatty acids. I put an exclamation mark. That's kind of my shorthand for activated fatty acids, so I can stop writing out activated all the time. So you add one activated fatty acid, and that goes on carbon 1. And you have a monoacylglyceride 3-phosphate. Then you're going to add another activated fatty acid. So now you have fatty acids at position 1 and 2, making it a diacylglyceride with a phosphate on the third carbon. So there's your common precursor. From there we can turn it into fat, or make these other two things. We're going to go through each one of them. So all of these are going to start with 1,2-DAG-3P. So if we're looking at the triacylglyceride first, this is where we left off. You're first going to add water to it. So the phosphate is going to be knocked off and turned into an OH here. And it's a plain old DAG. You're going to add an activated fatty acid, which is going to replace that. So you have 3 fatty acids, and that's your triacylglyceride. This is going to happen because of insulin. If you have too much glucose in your system and you can't use it, you're going to store it as fat. Nothing new there. So it's a very simple option. Most of the alcohols are neutral or negatively charged. There's only 2 that are positively charged, which we'll talk about over here. So to make a acidic glycerol phospholipid, you're going to start with your 1,2-DAG-3P again. You're going to activate it with CTP. So the important thing to know is if you're making an acidic GPL, you activate the 1,2-DAG-3P. So once that's activated, you can add a negative or a neutral alcohol. We'll use inositol as our example here. So we're going to add that, and you're going to have phosphatidylinositol. That's your acidic GPL. This is the most important thing, is what is being activated. In this case, the fatty acid, or the DAG. Now to make a neutral GPL, we're starting out the same precursor. You're going to add water to take off the phosphate. So it's going to look like this. Here's your DAG, the two fatty acids, and OH ready for binding. The difference with a neutral is, first of all, you only have two options. You can only use choline or ethanolamine. Those are your only two positive alcohols that we're talking about. And in this case, for neutral, you're going to activate the alcohol. So first you're going to add an ATP, and then in the next step you're going to add a CTP. I don't think the intermediate step matters. Just know that you add both an ATP and a CTP to get CDP alcohol. So it's your activated alcohol. If we're using ethanolamine for our example, we're going to take CDP ethanolamine and combine it with our DAG. Again, two separate things happening, and then this is combining them. So you're taking your activated alcohol plus DAG, these two equal phosphatidylethynolamine. It's neutral because the positively charged alcohol balances out the negative charge from the phosphate. So overall this has a net charge of 0, whereas the other one will have a net charge of at least a -1. So practice writing this whole thing out, writing out the different options. You can look at the old test for examples of how he asks it. What he usually wants you to know is mainly if you're activating the alcohol or if you're activating the 1,2-DAG-3P. So what about degrading the glycerol phospholipid? Here's our glycerol phospholipid, and you have 3 enzymes that can break it apart. There's another slide right after the one that looks kind of like this. This is just the more simplified version of it. That'll give you the actual reactions. PLA1 breaks off the fatty acid carbon 1, PLA2, carbon 2, and then rather than PLA3 they call it phospholipase C. And that breaks it off right here. He makes note that plants have a phospholipase D. They can break off just a free alcohol here, leaving all of this intact. So if you see this, he could list out all the reactions and say which one does not occur in humans. And if you see the one that's a free alcohol, that's the one he's talking about. So the product of phospholipase D would be 1,2-DAG-3P plus an alcohol. Again, that's all listed on the next slide. Next topic is sphingolipids. I always expect him to ask something like, these are 18 carbon molecules, so you can always kind of keep those in mind. He doesn't ask about the intermediates, but he will ask about what it starts with. So know that's a palmitoyl-CoA plus a serine is your amino acid that's important in sphingolipids. Those are going to both make ceramides. Ceramides have 2 options. You can add a phosphatidylcholine to make it a sphingomyelin, or you can add an activated sugar, UDP glucose, and make it a cerebroside. Cerebroside is the monosaccharide attached to this fat molecule. If you add just a couple more sugars, you would get a globoside. If you add a bunch more sugars, you're going to get a ganglioside. So all of these are your sphingolipids, all derived from palmitoyl-CoA and serine, with ceramide being the most immediate precursor. With the gangliosides, there's one clinical thing, the TSD or Tay-Sachs disease, and you can't remove, it's just more say you can't degrade gangliosides. What you can't remove is the terminal sugar. So it might be a question coming from there. One thing I didn't put on there, there has a slide all on its own that says sphingosine and calls it an aliphatic amino alcohol with a double bond between carbons 4 and 5. So he could, just write out aliphatic amino alcohol and list a bunch of things that look similar, but no, the answer is sphingosine. Next topic is cholesterol synthesis, which is nice because you just need to know the metabolites, not the enzymes. So it goes from acetate to mevalonate. And we're going to talk about these intermediate steps in just a second, but this is kind of the overview of it. It goes to an activated isoprene after that, into squalene, and finally you get cholesterol. So we're going to zoom in between acetate and mevalonate. And this should look very similar to what you studied in Unit 10 as far as making ketone bodies, because it starts out exactly the same pathway. You start with 2-acetyl-CoAs, and it turns it into aceto-acetyl-CoA via thiolase. Add in another acetyl-CoA onto that, and you're going to get HMG-CoA, same enzyme, HMG-CoA synthase. And in the previous unit, we went from here into ketone bodies. If you're going to make cholesterol, you're going to go to mevalonate via the most important enzyme in this unit is HMG-CoA reductase. It's nice and dependent. It's using 2 NADPHs, and this is going to be the one we're going to talk about right now as far as regulation. So this is the only really enzyme you need to know, but do know the order of all of these steps. Regulation is pretty simple overall. You're regulated by a few key things. Like everything, insulin or PP1. You eat sugar, you're going to make fat and cholesterol. So this enzyme here is the HMG-CoA reductase that we just looked at right here. That's the enzyme being regulated. Epinephrine or glucagon will create the pKa, so that will inhibit HMG-CoA reductase. AMP kinase will also partially inactivate HMG-CoA reductase, so that's another one that will inhibit this process. So that's the hormonal regulation. The other part of it has to do with the amount of cholesterol you have. So if you have a high amount of cholesterol here, the high amount of cholesterol is going to provide negative feedback saying stop making more cholesterol. So that's going to have another inhibitory effect on HMG-CoA reductase. If you have a large amount of cholesterol, it's going to try to stop converting it to LDLs as well. Like, we have enough LDLs, let's slow down this process. So high cholesterol inhibits HMG-CoA reductase, inhibits production of LDL, and you're going to try to shunt some of the cholesterol away and store it as cholesterol esters over here. So high concentration of cholesterol is going to stimulate ACAT, which is turning cholesterol into cholesterol esters. That's the main step he's going to ask. There's a slide that says regulation of HMG-CoA reductase. It summarizes most of this. That's another one to read over if you like it in text form rather than the graphic form. So there's a slide we saw in glycolysis that said regulation by AMP kinase. I would review that slide and know what it does. AMP kinase is one of his favorites. There's another slide called steroid hormones. Just cholesterol makes all your steroid hormones, and you should know all that from endo. So endocrine should have kind of taken care of that slide, but he will ask at least one question on that one, so make sure you know the steroid hormone slide. So other functions of cholesterol, you use that to make biosalts. So you turn cholesterol into cholate. You're going to add ATP and a CoA to get cholyl-CoA. And from cholyl-CoA, you can either add a glycine or a taurine. So a regular amino acid or some sort of specialized amino acid, and they're going to give you glycocholate or taurocholate. So know that if he asks what makes taurocholate, you need taurine, you need ATP, you need CoA, you need cholesterol, you need cholate to begin with. The most immediate precursor is cholyl-CoA, so those are a couple ways he might ask about biosalts. One other thing mevalonate can do besides just make cholesterol is make 3-isopentyl pyrophosphate. This is on the second to last slide. Don't need to worry about the intermediate steps to it, but you do need to know that it comes from here, it makes this, and this is the very last slide. It's called Overview of Isoprenoid Biosynthesis, and you'll definitely see at least one question coming from that, being, which of these does not come from 3-isopentyl pyrophosphate, or which one is not derived from isoprenoid. That'll be the type of questions he asks. There's no real trick to memorizing it other than all of your lipid-soluble vitamins, so A, D, E, K, all start here. D specifically goes from here to cholesterol to vitamin D, but if you see any of these, those are all derived from isoprenoids. So make sure you know that last one for this test. Study Unit 10 the most, obviously. I think last try there were 30 questions coming from Unit 10 and 10 coming from Unit 11, and these are the main topics that he will likely ask over. So good luck.